How did we get here? We used to keep everything in silos, nice and neat, right? We had storage, and then we had compute and network, all separate silos. In fact, compute had its own silos. Servers were local to the users, and they were grouped by function, right? We had mail servers, database servers, and so on. Then we had higher speed, wide area networks, which brought us data center consolidation, and we started moving all of our eggs into some very well air-conditioned baskets. And then came virtualization, the hypervisor. Probably our biggest jump ever for optimization. Now one server could run multiple operating systems. Applications could think that they were still siloed. Well, that then brought us multi-tenant data centers. Now compute could be offered as a service to your own enterprise or others. But here's the challenge. This hyper-virtualization has created what I call separation anxiety. You see, virtual machines grow like weeds. They're very portable, and we can do a lot of great things with them. But the network insists that your identity, and thus your policy, is tied to where you're located. Well, VLAN, subnets, security rules, and old-fashioned manual labor, these kind of things have kept it flowing for quite a while. But the complexity has reached a tipping point, and anxiety has firmly set in. Success can only be achieved when there's a harmony between the applications and the network, because they're both critical. Now, many answers have been proposed. In fact, two worth highlighting here: software-defined networking, or SDN, and network virtualization. SDN, though, means different things to different people. In general, it's some kind of abstraction between the control and the data planes, but there's a new element called the SDN controller. This is another bit of software here that should handle all the instructions between the applications and the network. This is all good work. It's interesting concepts. They're worth pursuing, but they fail to solve the problem. The SDN Band-Aid is ultimately just another layer of complexity. Now take network virtualization, which pretends the network is not really there. Just encapsulate everything on layer 3 and drive with your eyes closed. Complexity still remains, even if it is harder to see. It's just a different kind of Band-Aid. So true abstraction, isolation, and independence are needed for the network to truly support these dynamic workloads. And to truly get rid of the complexity, we need a do-over. Well, to do it over right, we need to follow a couple of requirements here. First off, the application must come first. There's no reason anything else exists except to support the apps. But also, applications cannot be touched, period. Don't touch them. And the third one, however, is keep it simple. I mean, some engineers know their apps. We got our app experts. Some engineers know their network. Both of these guys are valuable, and they need to be able to communicate very easily for this kind of thing to work. Well, Cisco's application-centric infrastructure has achieved all of this. Let's look at just 3 ACI concepts to help get you started. Application network profiles, fabric, and stateless hardware. But first, what is an application? It's not as singular as you would think. A simple web application has at least 3 logical tiers. Users interact with a web tier that will then talk to back-end application and database tiers. So is that the app? No, not yet. Now you have network services functions between each of these tiers, like QoS, load balancing, security. In a nutshell, it's all the policies, right? Take Oracle, for example. I mean, it could easily have different personalities on the network. Is it development? Is it test? Or is it production? I mean, all of those look the same to the network, yet each need dramatically different policies. Well, ACI wraps all of this up in an application network profile. It's a logical mapping of how an application is going to look, connect, and be treated anywhere on the network. Suddenly, we have one simple interaction point for an app developer, a network engineer, heck, even management. Well, this policy now sticks with the app as it moves through every part of its life cycle. And when you're done with the app, all of its policy stuff disappears. None of that stuff stays on your network. It stays clean. And the ACI fabric, which is our second concept here, is made up of the Application Policy Infrastructure Controller, the APIC, plus those stateless hardware switches, our third concept. So the switch architecture is a leaf-spine layout that enables linear scalability and robust multipathing, completely optimized for east-west traffic so common to data center applications. And it scales so easily. In fact, each spine switch you add creates another network path available for load balancing. And it's a very open design too. The APIC exposes a northbound API for access to all of the control functions. The southbound API opens up third-party network services for even more policy control. These application profiles are used by the APIC to push logical topology and policy definitions down to that stateless hardware. This is a complete reversal from traditional architecture where ties between VLANs and subnets and firewall rules are tightly coupled, trying to meet dynamic application needs. ACI is a complete system, but without the complexity. Traverse any path in the network as if it was all virtual machines with layer 2 adjacency. Seamless mobility across physical, virtual, even geographically dispersed endpoints. Top-down control, bottom-up visibility with real-time telemetry and atomic counters. It's like an overnight success, 30 years in the making. ACI makes a lot of sense.